This is Mrs. O'Neill for AP Chemistry, Chapter 11, Section 2, Part 4, Dipole-Dipole forces. So again, this is going to be the second of 4 major intermolecular forces. So again, pause the video, fill in the blanks, read as you write, read the entire sentence, and then play to hear my words. So these dipole really just means polar molecules. So it has a dipole. Hopefully that makes sense, right? A pole that has 2 ends, right? Dipole, a pole with 2 ends. One end is positive and one end is negative. So if we have already a positive and negative end, almost like a ionic compound, then we have an attractive force from one positive of one molecule and the negative of another molecule. Now remember, these molecules are the same. We're talking about the same substance. We're talking about 2 polar molecules that are close together, that they're going to have some kind of attraction for each other because of that positive end of one and the negative end of another. So these are still kind of weak forces, but they are slightly stronger than the temporary dipoles, the London dispersion forces. Okay, so remember, I'm trying to get you to understand these in order of strength. So the first one we talked about with London dispersion forces, those are the weakest of all. So these dipole are a little bit stronger, but they're still considered weak. So again, here we have our the attraction forces versus the repulsion forces. So you have all of these dipole molecules running around, and again, it's the same molecule. So this compound is the same as this compound is the same as this compound. But because it's a dipole, again, a pole with 2 different charges, so now you're going to have some attractive forces between the 2 and some repulsion forces between the 2. And I believe in your notes, there's a spot where you can do a little drawing to make sure you're understanding what this really means. So you can either pause or again wait until this slide and then make sure to draw something, even if you need to rewind. So again, we have 2 molecules, a positive and negative end, so there's going to be an attractive force, and we also have your repulsion forces. So you have both going on. Again, this is a whole bunch of molecules at one time, and we're talking about the same molecule, the same compound, because you never just have one, right? You always have more than one atom or molecule in a substance that we're talking about. So pause, again, either rewind or make sure that you do some kind of drawing in your notes that represent the dipole attractive forces and the dipole repulsion forces. So remember that these dipole then can also experience London dispersion forces. So this is this van der Waals guy, and we don't talk about him too much, but he kind of said that, well, dispersion and dipole now forces can be together. Well, that's because if you have dipole-dipole IMF, you automatically have London dispersion IMF. And he kind of said, yeah, he's the one who kind of said that they're both included in that molecule. So we've already seen this. So again, here's the first equation, but then it is redone or changed around because we have to deal with the difference in pressure, difference in volume, and now we have to add, this is what's going on here, we're adding the A and B here, and the A and B again is talking about the attraction between those forces, and then the volume would also be adjusted. So pause, read over the first equation and what that deals with, but then read over the second equation because it's really important to deal with, again, the number of the mole, right? Always dealing with a mole of molecules. It's never just one. It has to be a lot of atoms or molecules that we're talking about at one time. And the idea of making that adjustment because this first equation kind of thinks that there's no attractive or repulsion forces between molecules, and that's what he did. Van der Waals kind of put those together, added that in there. So he added in the number of moles as well as those A and B, changing the equation slightly just to include that there is attraction and repulsion forces between atoms and molecules. So again, pause and read that over. All right, see you in class.